Hey guys, in this video I want to go ahead and continue talking about partial fraction decomposition, but this time we're going to talk about what we call repeated linear factors, okay? And if you notice here, whenever we're doing the decomposition for partial fractions, when you have repeated linear factors, you got to incorporate the constant for each linear factor. So let me see if I can give you a pretty good explanation here. You see how we have this rational expression right here? Well, when we go ahead and try to decompose it, okay, we have the x minus 2, and then we have the x squared, right? And remember we said that the degree on the top has to be 1 less than the denominator. Okay, so when that happens, you have, because this is a quadratic, you actually have bx plus c. Okay, this is a linear, and then this is a constant. Okay, now if we do that, that means that bx divided by x squared, okay, can be split up until c over x squared. Well, then you have the x and the x squared can simplify out, and you're left with this. And if you notice, you have b over x and then c over x squared, meaning that this x squared got split up into x to the 1 and x to the 2. So when you're doing these, you have to make sure you incorporate, okay, like this example here, that extra constant for those repeated linear factors. So if you had x, for example, x to the 4th power, you see here. So you have x plus 1 and x minus 2 to the 4th. So you would do the x plus 1, and then you do x minus 2, and then you do x minus 2 to the 2nd, and then x minus 2 to the 3rd, and x minus 2 to the 4th. So you have to incorporate all of those. The problem is it becomes rather tedious, but you would have to do that. And this is really important as you move on to the calculus, especially BC, where you're using partial fraction decomposition to solve some of those calculus problems. So what I did is, just for sake of time, I went ahead and started a problem to show you guys. So here we have problem number 1, and we have, this is our problem here. And if you notice, the degree on the numerator is bigger than the denominator. So what we're going to do first is we're going to divide. So long division, just from algebra 2. So x cubed here, and just make sure when you're writing this, guys, that it's in descending order. So look at x cubed, look at the x to the 4th. What do I need to make x to the 4th? You need an x. So now all you do is multiply the x times everything over here. Okay, so now x cubed times x is x to the 4th, x times 4x squared is 4x cubed, x times 4x is 4x squared. So you subtract that, the x to the 4th and the x cubes cancel out. 6 minus 4x squared is going to give you 2x squared. You bring down the 14x. Okay, well, I have x cubed here. What do we need to make a 2x squared? Well, there's nothing. We can't do anything else. So that's what we're left with. So we bring down the 12. This is my remainder. Okay, so my remainder here, this becomes, okay, this turns into this. All right, guys? So now what I'm going to do is I'm going to leave the x alone. I'm going to decompose this, okay? And you can see that the numerator is 1 degree less than the denominator. Okay, x squared and x cubed. But now what I do is we're going to go ahead and factor this guy. All right? So we factored out the x, and we're left with x squared plus 4x plus 4. Well, we'll factor out this guy. We're left with x times x plus 2 squared. All right, so that breaks down into a over x plus b over x plus 2, and then c over x plus 2 to the 2nd. So you see this guy is, it's like saying x plus 2 to the 1st, and then x plus 2 to the 2nd. So now that I have this, I'm going to decompose this, separate it. I'm going to have this guy here, multiply it out, because I want to just clean this up, get rid of everything in the denominator. So the denominators cancel out here. We're left with this. Right here, one of the x's cancels out, so we're left with the x squared. One of the x plus 2 cancels out. We're left with x and x plus 2. And the last one, the x squares cancel out. All right, guys? So now we have this. And just like we're doing our partial fraction, we're going to let x equal to negative 2. Why? Well, because I want to get rid of one of these so I can solve for the other. All right, so if you notice, if I make x equal to negative 2, this becomes a 0, this becomes a 0, and I can solve for c. So x becomes negative 2, there's a 12. Okay, so when I do the math here, negative 2 squared is 4 times 2 is 8. 8 plus 12 is 20. 20 minus 28 is negative 8. Negative 2 plus 2 is 0. Negative 2 plus 2 is 0. You're left with negative 2c is equal to negative 8, which is c is equal to 4. Great. And then we just continue on. We do the same thing again, but this time we're going to let x equal to 0. Okay, why? Because I see that over here we have cx. So I'm just going to put x to 0. So I do the same thing. 0, 0, we got the 12. X equals 0. Okay, and then b times 0 times 0 plus 2, and then c times 0. And then you can just continue doing the work. Here you get 0, 0, and that plus 12. And then 0 plus 2 is 2. 2 squared is 4. So you're left with 4a. This guy right here becomes a 0, and so does the c. So that's okay. All right. So now we have 4a. Sorry about that. We have 4a is equal to 12, and a is equal to 3. Great. So now we have c and we have a. Well, now we got to figure out the other ones. So let me move this real quick. So I ran out of room, but I'll do my best here. So now to find out c, we already know, to find out b, we already know a, we already know c. So now all you got to do is pick any x value that you want, okay, and use it to go ahead and figure out b. So what I decided to do is use the easy one, which is 1, x equals 1. So I used x equals 1, okay, here. And then I also used my values for a and c. So if you notice, a is 3, okay. So right here, we have a is 3, and then x is 1 plus 2. And then b is I don't know, x is 1, and then c is 4. Okay, and this guy here is my expression on the left side here. And I decided to use 1. And again, you can use whatever value you want. But when I do the math over here, I get 28. When I do the math over here to the right side, I end up with 3 times 9 plus 3b plus 4. Well, that's going to give me 27 plus 4 is 31. And that's going to give me 31 plus 3b is equal to 28. Well, if I continue it on, okay, and I solve it, all right, you notice there, 3b equals negative 3 and b equals to negative 1. Well, now I have all my constants that I need. 3 goes with the x, negative 1 with x plus 2, and 4 goes with x plus 2 squared. So hopefully that helps you out, guys. I'll try to do another example just from scratch, and I'll see you guys next time.